Welcome to this tutorial. My name is Hugo Guerra. Today I'll be showing you how to use Nuke 3D Tracker to track, project textures, and relight a completely normal shot to look like a creepy survival horror environment. With the advent of compositing applications like Fusion and Nuke, the borders of 3D and 2D are blurring even more. The entire setup of projection, 3D tracking, simple lighting and shading inside a compositing application is growing more and more in the film commercial pipelines of visual effects companies. Such techniques are not meant to replace a 3D pipeline in any way, but they will support and develop new ways of compositing, simple matte painting, roto, cleanup and relighting, making the entire pipeline faster and more in sync with the 3D department. In this tutorial, I'll show some of the 3D techniques I've developed over the years inside Nuke. We will use Nuke X powerful 3D tracker to achieve some complex 3D operations inside Nuke without having to go to a dedicated 3D software. We'll track a plate, calculate lens distortion, project new textures and relight the footage using the 3D system. The idea is to transform a normal room into a creepy survival horror inspired environment with blood, dirt and a fake flashlight effect in the room. This tutorial, it's not a full step-by-step tutorial, since I am assuming some knowledge of Nuke's 3D system and of compositing prior to this setup. I would like to thank Ron Gambar for making this footage available for this tutorial. Please visit his website at rongambar.wordpress.com. Start by opening the 3D tracking start.nk script that was provided with this tutorial. With that script, we can prepare our footage for tracking. That script will contain the footage that we are going to use to 3D track, and, not important for now, is the several Photoshop files of filters and textures that we are going to use throughout this tutorial. Important right now is the main footage that we have. I'm just going to press play so we can actually look at the footage in hand. And I'm also going to hit the space button so we can actually see the image in full screen. So this is the piece of footage that we'll be tracking. Now, in this stage, we'll prepare our footage for tracking. We will have to first undistort the footage and then make a first pass of tracking with the default settings. Always try the default settings first before making changes to the tracking parameters. We need to undistort our plate prior to 3D tracking. Otherwise, you might get poor results in the solve of the tracking, depending on how much of the lens distortion is in the footage. Also, tracking a distorted plate will lead to wrong points in 3D, since in the 3D system, the image is always perfect, and with no lens artifacts or distortion whatsoever. So let's start by bringing in the lens distortion node. Let's hit the space button again, and let's stop the clip. Let's start by going into the transform menu to select the lens distortion node. The lens distortion will be found on the transform menu. By hitting the lens distortion node, you will see that nothing has happened to your footage. This is because the lens distortion needs to calculate the amount of lens distortion first before it actually does something to the image. The lens distortion node basically has 4 tabs: the lens distortion tab, the image analysis, the grid analysis, and the line analysis. We can start by looking at the lens distortion tab. Basically, the lens distortion tab is the settings tab for our lens distortion. In here, we can select if we want to output a distorted or undistorted image or a displacement map to use later or to use on another application. We'll talk about this in detail in a few minutes. Also, you can select if you have a spherical or an anamorphic lens. Now, there are 3 ways in Nuke to do lens distortion. You can either use image analysis. Image analysis will basically analyze the entire clip, the 100 frames, and try to automatically calculate the distortion level of this footage. The second option is grid analysis. Grid analysis will allow you to use either a checkerboard or a thin line card to calculate the distortion. This is the most typical setup in production. Usually, a visual effects supervisor or a lead compositor or a lead 3D artist will go to the set of the footage, and it will, for a few seconds, put a checkerboard or a thin line card into the front of the camera that is filming the clip. This way, it can actually see the lens distortion in the lens by looking at that checkerboard. And then you can use the grid analysis to calculate. Unfortunately, this piece of footage does not have a grid for us to use this method, but this is the most common method. The third method is line analysis. Line analysis allows you to draw lines in the clip to try to calculate the lens distortion. It is a very good method if you have a lot of geometrical shapes in the footage. Because if it's, for example, a piece of footage with a lot of trees or forest or grass, then it will be very hard for you to actually know where should there be some straight lines. Also, be very careful with this method, because sometimes if you're not on set, you might be fooled by some lines that you think they are straight, but they are actually not straight. The one we are going to use on this tutorial will be the image analysis, because I do not have a grid, and I do trust Nuke for him to actually calculate a proper lens distortion from this clip, because this clip does not have any big movements. It does not have any people on the plate. It's a very straightforward shot. So once the lens distortion node is attached to the clip, let's hit the Analyze Image in the Image Analysis tab. Once we hit that Analyze Image, what's going to happen is that Nuke is going to go frame by frame, tracking features in the footage to try to understand where pixels move and where pixels don't move in the image. What's going to happen is that it's going to calculate automatically the distortion once it's done. So it's pretty much like a tracking software at this point. Now, a few minutes later, you should have a distortion value in the first tab of the node. You can now use this node to undistort and redistort our footage after all the CGI and compositing is done. If you select the lens distortion node and you hit the D button, the D button stands for disable, you can clearly see that the lens distortion node is now undistorting the plate. So by hitting the D, I can just compare it without any distortion done or with the undistortion done. At this stage, what we are going to do is we are going to render a displacement map out of our lens distortion node. This is because the lens distortion node is a very slow node. So we do not want such a high processing node to be part of such a complex script. Otherwise, the render times will be very big. And we want to always try to cut the render times as much as we want. Now, to use the STMap, we are going to bring an STMap node from the Transform menu. And we are going to change the lens distortion output type from image to displacement. Now, when we change the output type of the lens distortion to displacement, the image stops being undistorted, but we now have a new file stored in the motion channel of our file. This green to red value file will be the distortion displacement map that we will use together with the STMap to undistort our footage on a much more practical and fast way. Now, as I said, select the displacement in the output type and then save the distortion map by using a write node. Now, we're going to bring in a write node, so if we go in after the lens distortion, we hit the W button, a write node will show up. Once we have a write node, and I just bring my viewer back to RGB, in the write node, what we are going to do is we're going to select a place where we want to save this. I already have a place that I've saved, so I'm going to just do it again. I've already saved it once, but we can do it again. I am going to call this undistort.exr. I'm going to hit save, And now, one important thing is that you need to make sure that the data type of your EXR is full 32-bit float. This is important because we want to make sure that we bring into our lens distortion every single bit of information that we have. So we do not want to crop the information value with 16-bit. So keep it in 32-bit float. And also, we're not interested on rendering out the RGB because we don't need this image right now. We only want the motion. So go ahead to the Channels tab and select Motion as the output of our undistorted EXR. Once you are ready, you can hit the Render button. Now, you do not need to render 100 frames. You only need to render 1 frame. So I am going to change my range from 1 to 100 into only 1. This means it will render just 1 frame. This is because the lens distortion information does not change from frame to frame. So there is no need whatsoever of rendering all of it. It's just a waste of space. I'm going to press OK. Now it's rendered the file. Once the file is rendered, I am going to bring in the file. I'm just going to press escape so we have a little more space. And I'm going to make a little change here. I'm going to do 2 branches here by using the dot. You can summon the dot by pressing the dot button. And I'm going to basically branch out 2 little branches here. So I'm just going to have one, which was the lens distortion and the right node. And now I am going to hit the tab button and hit ST map. So by hitting the tab button, the shortcut for the nodes will show up. I'm going to write ST map, and then I'm going to select the ST map, and now we have the ST map node. Now the ST map node has 2 inputs. One input is source, which will be connected into the read node, or better to the footage, and the STMap input needs to be connected to the file that we just saved with this right node. So I'm going to hit the read node. I'm going to hit the R button. So hitting the R button will open the read node. Once the read node is open, I'm going to select the undistorted.txr file that we've just saved. I'm going to hit open. Now we have the file here. I'm just going to close the properties of that file, and I'm going to plug it into the STMap input. Now, if I put the STMap into the viewer, you can see that nothing has happened. This is because the STMap has 2 options, basically. We need to first tell him what channels we want to affect with our STMap. And second of all, we need to select what channel has the lens information. That is called the UV channels. So in the UV channels, I have to go and pick up the channel where we've stored the lens information. We know for a fact that that channel comes from the motion channel. So I'm going to select motion, and soon as I select motion, you can clearly see that the STMap is now affecting my footage. So if I disable and enable the STMap, you can see that I am having the exact same lens undistortion as if I was using the lens distortion node. So now we are ready. Now that we've done undistortion, we are now ready to go to the second stage, which is basically to 3D track this piece of footage.